Hi guys, let me jump back in here. Sorry, I had to hop off the last video. So in this video, I'm just going to focus on, we have the rate law, how do we find the rate constant, and then the units for it. So for this part, we already got to our rate law, okay, which was the first step. And now we want to find that rate constant. So once you have your rate law, you're just going to pick any of these experiments and use its initial rate and then the concentrations for that experiment and plug it all in. I almost always just pick the first one because it's the top one. So I am going to just simply plug this all in. Now I'm looking for the rate constant. So you can rearrange this ahead of time if you want, but I'm just going to set it up like this because most of you guys are going to do it this way. So the rate for my first reaction is 9.85 times 10 to the negative 7th, and that's going to be my mole over liter per second. And that's going to be equal to K, which is what we're looking for. And then we have our concentration, which is 2.5 times 10 to the negative third. I'm going to actually write this out as moles per liter instead of molar here, raised to the first. Then I'm going to have the concentration of iodine, which is 1.5 times 10 to the negative 2 mole per liter squared, because it's, cubed, because it's the third order. And then for H plus is 1.5 times 10 to the negative 2, which is mole per liter squared. Okay, and then it's just a matter of really carefully plugging in the values in your calculator. So once you actually plug in the values, so you take your 9.85 times 10 to the negative 7th, divide it by these values, making sure you cube and square them appropriately. Okay, you should end up with 5.2, and I'm rounding it to 2 sig figs just because of the concentrations, times 10 to the 5th, okay, or this will be 520,000 number, okay? So that's how you get the value of the rate constant, and that is at that temperature going to be true for any set of concentrations that you're starting with. If the temperature changes, this does get affected, but we'll deal with that shortly. So then what we have to do is know the units. And I told you in class, like, you need to know how to find these units just as much as knowing the value here. So one way to first do it is that generic setup where in the notes, it shows it as this, order minus 1 over, and our unit for time was seconds here. Okay. You can also think of this as L raised to the overall order minus 1 mole raised to the order minus 1 times S. Okay, you can think of it that way too. So if we add up, our overall order is 1, 3, and 2. So 1 plus 3 plus 2 gives me 6. So that's my total overall order of reaction. So you can simply just plug that into here. So this would be 6 minus 1, and then the same thing here, times S. So this is going to give me my units, which would be L to the 5th over mole to the 5th times second. Okay. One little thing, if like you blank out and you don't remember this, you can still use your setup here. Keep in mind. So you would have your mole over liter per second, because that's this unit here. And I'm going to divide it, by these values here. So that would be, once I divide that, it would flip it. So this would be liters per mole, and then this would be liters to the third over moles to the third for our iodide ion, and then this would be liters to the second, moles to the second for the hydride ion. So when you cancel them out, only 1 liter and 1 mole would cancel out. So when you combine the terms, you would still get liters to the 5th, moles to the 5th times second. Oops, sorry. Okay, so you'd still get back to that value there. Okay, so you need to be able to easily find these units one way or another. Also, knowing how this works can help you take units and know what the order of reaction is. So you can kind of work the other way. So I can look at these units and know that this must be a overall 6th order. Okay, so that's a little bit about just having to find the rate constant and how to determine those units. So hopefully you'll feel a little bit better before you do the practice tonight.